Hello students, welcome to my channel Bhavya Physics. Today we are going to discuss 2 marks questions from the model question paper 2 of the year 24-25. Before moving to the questions, if you are new to my channel, please subscribe my channel and press bell icon to get the notification of all the videos. If you are already subscribed, please like my videos and share to your friends who are studying in 2nd PU or class 12. And if you are having any opinion, you can comment in the comment section. Okay, now let us start the first question. It's 2 marks questions. The first question is, the charges are additive in nature. Explain. So this is from first chapter. So we know that charge is having 3 properties. So the one is charge is additive in nature, charge is quantized and charge is conserved. So this is a first property. Here the total electric charge of an isolated system is equal to algebraic sum of all the individual charges located at different parts of that system. So that means when we are adding the charge, we need to consider its sign. Okay, there are positive charges as well as negative charges. So the total charge is algebraic sum of the individual charges present in that system. Okay, so this is a statement. Now, so if you are having some charges in a system containing of charges Q1, Q2, Q3, so on, then the total charge of the system is Q1 plus Q2 plus Q3 plus so on Qn. For example, now we are having some charges like plus 1 coulomb, plus 2 coulomb, minus 3 coulomb, plus 4 coulomb and minus 5 coulomb. So while adding, you need to consider its positive and negative sign. So plus 1 plus 2 is plus 3. So plus 3 minus 3 becomes 0. Plus 4 minus 5 is minus 1 coulomb is the answer. Okay. The second question is from second chapter. What is an equipotential surface? What will be the shape of equipotential surfaces corresponding to single point charge? As its name indicates, equipotential surface means the surface having same potential throughout it. Okay, the surface is having same or constant potential. So the answer is, it is a surface with constant value of electric potential at all points on the surface. So if the charge is single point charge, then equipotential surfaces are concentric spherical surfaces having charge at the center. Okay, so how the surface looks like here, if there is a charge, okay, and the surface is concentric spherical surfaces, right? Each surface is having same value of potential. All this point is having same potential. Okay, in a given surface the potential remain same. For example, if this first one is having 10 volt, the second one is having 7 volt, the third one is having 4 volt, like that. Okay, so as we move away from the charge, potential decreases. It is inversely proportional to the distance, right? In the given surface is having same potential. Okay. The next question, give any two differences between current and current density. So you can make two columns, current and current density, but here I have written all those together. Current means it is first is a definition. It is a rate at which electric charge flows through a conductor. That is first point. Okay, so that you can write in mathematical, I is Q by T. Second point is it is a scalar quantity, and third point is it is independent of area of cross section of the conductor. Whereas current density is, it is a rate at which electric charge flows through a conductor per unit area. That is, we can write it as I by A. Okay, electric charge flows through a conductor per unit area. Is this clear? So charge flows through a conductor is current per area is current density. Okay, so I by A or Q by T by A. So second point here we have written it is scalar quantity, whereas current density is vector quantity. And third point is current density depend on the area of cross section of the conductor. Okay, please note down this. So this is one of the important question. Next one, moving coil galvanometer gives a deflection of 10 divisions when 200 microampere of current is passing through it. Find the current sensitivity of the galvanometer. Current sensitivity is given by this relation. Okay, current sensitivity is theta by I. Okay, theta by I is current sensitivity. That means we know that galvanometer deflects according to the current in the circuit. Even if for small current, galvanometer shows large deflection. So therefore, this galvanometer is very sensitive to current. Then how to calculate current sensitivity? It is theta by I. Okay. So theta means deflection produced in the galvanometer, that is 10 division. Current passing through that circuit is 200 microampere. Microampere is 10 to the power minus 6. Substituting will get 5 into 10 power 4 division per ampere. State Faraday's laws and Lenz's law of electromagnetic induction. So Faraday's laws, there are two are there. So you should practice this. It's very important question. According to Faraday's law, when there is a change in magnetic flux linked with the coil, an EMF is induced. It exists as long as there is a change in magnetic flux exists. Okay. So first statement is very important. When there is a change in magnetic flux linked with the coil, an EMF induced. Okay, when EMF induces whenever there is a change in magnetic flux linked with the coil. So this is very important point. When magnetic flux linked with the coil changes, EMF will be induced. Okay, and that induced EMF exists as long as there is a change in magnetic flux exists. If there is a changes in the magnetic flux, if d phi is there, means there is a EMF. Okay, this is first point. The magnitude of induced EMF in a circuit is equal to time rate of change of magnetic flux through the circuit. So time rate of change of magnetic flux can be written as d phi by dt, that is equal to magnitude of induced EMF. This is second point. So there are two statements in Faraday's law. Okay. So here already I mentioned d phi b is phi is nothing but magnetic flux. B stands for magnetic. So flux is phi, magnetic flux is phi b. D refers to change. So d phi b is a change in magnetic flux in time dt. Then induced EMF is E is minus d phi b divided by dt. Okay. So Lenz's law, which tells about polarity of induced EMF. So polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. Okay, so both the statements are very important. Next question, name the electromagnetic waves used in the following applications. The first one is the radar system used in aircraft navigation, the remote switches of household electronic systems such as TV. So, in radar system used in aircraft navigation, we are using microwaves. Microwaves are used in the radar system. Okay. And infrared waves are used in remote switches of household electronic systems such as TV. Okay. Next one. How is total energy of an electron revolving in an orbit of hydrogen atom related to the principal quantum number of the orbit? What is the significance of negative sign in the expression for total energy of electron in a hydrogen atom? So, the total energy of electron revolving in an orbit of hydrogen atom is inversely proportional to square of the principal quantum number. So, how to write that? E can be written as E is equal to minus 13.6 divided by n square in electron volt, right? So minus 13.6 by n square electronic volt. So therefore, total energy of electron is inversely proportional to square of the principal quantum number. Okay. So why negative sign here? Negative sign indicates that negative sign in the expression for total energy of electron in an hydrogen atom is that electron is bound the nucleus, right? That is, energy will be required to remove the electron from the hydrogen atom. So since electron is bound to the nucleus, it is under the control of nucleus. Energy expression should have negative sign. If it is positive, means it is away from that, it is not bound to the nucleus. So if it is coming out of the system, then its energy will be positive. So if energy is negative, means that is bound to the nucleus. That's why electron must have total energy of negative. Next, what are intrinsic and extrinsic semiconductor? Intrinsic is a pure semiconductor in which electrical conductivity is due to the thermally generated electrons and holes, right? So because of temperature, there is a breaking of covalent bond and electrons and holes will be generated. So that is in case of intrinsic semiconductor. It is a pure semiconductor. In this semiconductor, number of electrons and holes are always equal. So if one electron comes out, then vacancy is created. That vacancy is called as hole. If two electrons comes out of the atom, then two holes will be generated. So number of electrons and number of holes are always equal. So this is due to thermally generated, means when the heat, because of heat energy, covalent bond breaks, and when there is a breaking of covalent bond, electron which comes out of the system atom, and hence there is a vacancy created, which is denoted by hole. So that's why holes and electrons are always equal in number in case of intrinsic semiconductor. Whereas extrinsic semiconductor is a impure semiconductor in which there is a doping, right? So when we are adding some other dopant atom, then what happens here? One kind of charge is always excess than the other. For example, holes are majority carriers than electrons, or electrons will be more number than holes. So therefore, there is no balancing of electrons and holes. Okay, number of electrons and holes are not equal in case of extrinsic semiconductor. Extrinsic semiconductors are mainly of two types, P type as well as N type. Okay, P type means here holes are more in number than electrons. In N type, electrons are more in number than holes. So these are the important 2 marks questions asked in model question paper 2nd of 24-25. So please go through these answers and write down in your notes. Note down all these answers. And if you have any confusion, you can ask me in the comment section. Thanks for watching.